In this problem, we're given an f of x equation, the standard equation to start with, and then what they do is they make some adjustments to that x value on the inside of our f of x equation, and they want to know how that would affect the actual graph. The crazy thing about this is whenever we have fractions inside there, so if I'm looking at a fraction, like we are in this situation, f of 1/3 x, then the terminology you want to look for in your answer is going to be stretched. And the weird thing is it's going to be stretched by the flipped number, so the flipped fraction. So in this situation, what we're looking at if we flipped our fraction would be, instead of 1/3, it would be 3/1. So our answer would be it's stretched horizontally by a factor of 3. The other way that you could see this, it would have had whole numbers. And so if you have whole numbers instead of fractions going on inside there, in that situation it would look something like f of and then a 3x. Then the word you'd be looking for would be compressed, and it actually would stay the same. You would not flip. And so in this situation, you would say it's compressed by a factor of 3. And if you're looking for any of the ones that would have reflected over the x-axis, that would mean that you have a negative sign sitting in front of whatever is happening to the x value on the inside. So to tell the difference between the fractions and the whole numbers, the answer is going to be stretched for fractions, compressed for whole numbers. The factor is going to be the flipped version if you're looking at the fractions, and it'll stay the exact same if you're looking at whole numbers. And then if you're looking for anything that says reflected about the x-axis, you would just have a negative value sitting up in front of that f. So again, our answer, because it's a fraction, would have been stretched horizontally by a factor of the flipped version of 1/3, which is 3.